Imagine dropping into an abyss so deep that not a single ray of sunlight has ever touched its bottom. Imagine water so ancient it has flowed uninterrupted for millions of years. Picture creatures so unique they've evolved in total isolation, under conditions we once thought unlivable. Welcome to the hidden world beneath Earth's deepest lakes. These aren't just watery landscapes, they are colossal geological formations, time machines of biology, and gateways to understanding life at its most extreme. We're talking about places that reach deeper than the Grand Canyon, that hold more fresh water than entire continents, and that defy what we thought possible for life. In this episode of Know, we embark on a journey to Earth's deepest and most mysterious lakes, where pressure crushes, light fades, and yet, life finds a way. From Lake Baikal in the heart of Siberia to subglacial lakes sealed beneath Antarctica, these aquatic worlds are not just fascinating, they're vital to understanding our planet's history, present, and even its future. So strap in, because this isn't just a dive into water, it's a descent into the unknown. Our first descent begins in Siberia, Russia. Surrounded by taiga forests and snow-covered peaks lies a lake so ancient, so vast, and so deep it might as well be an ocean. This is Lake Baikal, Earth's oldest and deepest freshwater lake. At its deepest point, Baikal plunges to 1,642 meters, or just over a mile straight down. That's deeper than many parts of the ocean floor. But it's not just about depth. Lake Baikal is estimated to be 25 to 30 million years old, making it the oldest lake on the planet still in existence today. What does that mean? It means that Baikal has acted as a living biological archive, continuously supporting evolving ecosystems throughout epochs of Earth's history. It has survived ice ages, continental shifts, and mass extinctions, and in doing so, it has become one of the most biodiverse freshwater systems in the world. There are more than 1,700 known species living in Baikal, and over 60% of them are endemic, found nowhere else on Earth. Meet the Baikal seal, or Nerpa, the world's only exclusively freshwater seal. How did it get here? No one knows for sure. Some theories suggest ancestral seals swam inland during the last interglacial period. Others propose a more ancient migration during high sea levels. Then there are the amphipods, tiny shrimp-like creatures, some transparent, others luminescent, all uniquely adapted to Baikal's crushing pressures and near-freezing temperatures. At the microscopic level, the lake teems with planktonic life, like Epischura baikalensis, a zooplankton that filters and cleans the water. It's so efficient, in fact, that Baikal remains crystal clear with visibility exceeding 40 meters in some areas. Even sponges here are extraordinary. Massive, green-colored filter feeders that cling to rocks like alien organisms, some forming colonies over a meter wide. Baikal isn't just deep biologically, it's deep geologically. It sits atop the Baikal Rift Zone, where the Earth's crust is slowly pulling apart, much like in the East African Rift. The lake is literally growing wider each year, making it a future ocean in the making. Scientists drilling sediment cores from Baikal's lakebed have discovered layers upon layers of preserved pollen, volcanic ash, and fossilized microorganisms. These offer climate records dating back millions of years, helping us reconstruct Earth's environmental history in unprecedented detail. So Lake Baikal is not just a lake, it's a living time capsule, a geological wound and a biological wonder all rolled into one. But Baikal is just the beginning. Across continents, hidden in valleys and mountain ranges, lie other deep lakes, each with its own story, its own secrets, and its own strange inhabitants. Let's head now to East Africa, to the shores of Lake Tanganyika. Shared by 4 countries, Tanganyika stretches like a liquid ribbon between highlands. It is the second deepest lake on Earth, reaching depths of 1,470 meters. Tanganyika is also a rift lake, formed by the same tectonic activity shaping Baikal, but its biodiversity is completely different. Here, we find the cichlids, a family of freshwater fish that have undergone an evolutionary explosion. Over 250 species inhabit Tanganyika's waters, many evolved to fill specific ecological niches. Some graze algae from rocks, others hunt insects, some even mimic dead fish to lure prey. In evolutionary biology, Tanganyika is a poster child for adaptive radiation. How one species can diversify rapidly in an isolated environment. But the deeper we go, the stranger things get. Tanganyika is stratified into layers. The top 100 meters or so are oxygenated. That's where most life is. Below that, a hypoxic zone, no oxygen, no fish, just bacteria and archaea that thrive in darkness and feast on sulfur. Next we travel to the Caspian Sea, the largest enclosed inland body of water on Earth. Although often called a sea, the Caspian behaves like a lake. No outflow, surrounded by land, and isolated since the Pleistocene. It's slightly saline, home to ancient species like the Caspian sturgeon, whose ancestors swam alongside dinosaurs. These massive fish, some over 4 meters long, are critical for caviar production, but overfishing has brought many to the brink of extinction. The Caspian also harbors oil and gas fields beneath its floor, making it a geopolitical flashpoint and one of the most ecologically vulnerable aquatic systems in the world. And what about the lakes you can't even see? Beneath the ice sheets of Antarctica, scientists have discovered over 400 subglacial lakes, trapped under kilometers of ice for millions of years. The most famous? Lake Vostok. Sealed beneath 4,000 meters of Antarctic ice, Vostok has been isolated for at least 15 million years. And yet, samples taken from above its surface have revealed microbial life. What kind of ecosystem could exist in total darkness, under such pressure and cold? We still don't fully know, and therein lies the mystery. You might be wondering, how can anything survive in these conditions? Extreme pressure, no sunlight, freezing temperatures, low oxygen, sometimes no oxygen at all. The answer lies in a unique category of organisms, extremophiles. These are life forms that thrive in conditions fatal to most known organisms. Some rely on chemosynthesis, a process that uses chemical reactions, often involving sulfur or methane, to produce energy. You'll find them in hydrothermal vents at the bottom of oceans, but also in the anoxic zones of deep lakes. In Baikal, Tanganyika, and Vostok, chemolitho-autotrophic bacteria break down hydrogen, methane, and sulfur compounds, forming the foundation of unique food webs. Some deep lake microbes are methanotrophs. They consume methane, reducing greenhouse gas emissions naturally. Others form biofilms on rocks, altering the chemistry of the lakebed, helping researchers understand the biogeochemical cycles in these remote ecosystems. There are even radiation-resistant microbes found in deep subglacial lakes, organisms that challenge what we thought was biologically possible. The implications? If life can survive here, in near-alien conditions, then perhaps life could exist in extraterrestrial oceans. Consider Europa, Jupiter's icy moon, or Enceladus, a moon of Saturn. Both have subsurface oceans beneath layers of ice, and both show signs of hydrothermal activity, similar to conditions in Earth's deep lakes. What we learned from Baikal, Vostok, and Tanganyika could be the blueprint for finding life beyond Earth. Reaching the depths of these lakes is no easy task. You can't just scuba dive into Lake Vostok, or drop an anchor into Baikal and call it science. Exploring these worlds requires advanced technology, ROVs, remotely operated vehicles, AUVs, autonomous underwater vehicles, and highly specialized sampling equipment. In Lake Baikal, Russian scientists have used deep-diving submersibles to map the lakebed, study methane seeps, and recover unknown microbial species. At Lake Vostok, researchers drilled a borehole over 3.7 kilometers deep, carefully preventing contamination using pressurized, sterilized equipment. At Lake Vostok, researchers drilled a borehole over 3.7 kilometers deep, carefully preventing contamination using pressurized, sterilized equipment. Today, NASA and the European Space Agency are partnering with limnologists, lake scientists, to develop probes that could one day explore icy moons using the same principles. Today, NASA and the European Space Agency are partnering with limnologists, lake scientists, to develop probes that could one day explore icy moons using the same principles. But technology is just one piece of the puzzle. Conservation is critical. As we gain access to these environments, we must also protect them. Pollution, warming temperatures, invasive species and overfishing are rapidly threatening many deep lakes. Lake Baikal has seen rising levels of algal blooms, once unheard of in such a cold, clean lake. Lake Tanganyika is warming faster than the global average, disrupting oxygen levels and fish populations. What we explore, we must also preserve. These lakes are not only scientific frontiers, they are cultural, ecological, and climatic treasures. Beneath the surface of Earth's deepest lakes lies a world most will never see. A world teeming with life, shaped by fire and ice, pressure and time. They are ancient. They are mysterious. They are essential. From the Baikal seal to Antarctic microbes, from methane vents to tectonic rifts, these lakes remind us that life is more resilient and stranger than we can imagine. And most importantly, they show us how much we still don't know. So the next time you look across a still lake, remember, you're not just looking at water, you're looking into a hidden world, and perhaps the key to life on other worlds as well. What other secrets lie beneath the surface? The only way to find out is to keep diving. Know more. Be more.